there we go. There we go. Okay, last time we finished up just talking about statements and expressions. And I was telling you too how you didn't need to be worrying too much about sitting down and memorizing these specific things. Like, yeah, it's important, but the reason I'm showing it, and the reason I've showed you a lot of the stuff so far, is there's a lot of jargon, right? There's a lot of words we use very commonly that you don't know yet, so I gotta show you those things. Some of the content we've seen so far is very obviously like, oh, variables, yeah, oh, okay, print, good. Things that you gotta know you're gonna be using a lot. And a lot of the other stuff is just that jargon we've been talking about. Oh, actually, I did have a question from more than one person about the course website. So the course website is actually generated by some software based on all the information here. This is called GitHub. Anyone ever heard of that before? A couple people. So it's all of the course content, with the exception of the assignment solutions, are on GitHub. All of it. You can go here, you can navigate, and you can even find topics. Let's see, like input. Yeah, input. Great. Like here's the content, but it's actually, the content actually just looks like this. But the website software I use just generates the websites based on this information. So it's pretty cool. And all of the code that we will be using is also here as well. So if there's ever some code from like the course website, yeah, you can copy paste it from the course website, it'll be just fine. But you could actually just download all the code from here as well. Come on, if I can find it. There we go. SRC, for like source. And we're probably going to get to the functions topic today, so here's the code for the functions topic. It's all right here, which is pretty cool. But what makes, to me, what makes storing all this information on GitHub really interesting is GitHub, for those of you that don't know, which was most of you, GitHub is this really popular website programmers use to just store all of their code. It's great because it does like version controlling where, if you made a mistake, you can revert back to a previous version really easily. All changes are always recorded, so you can always know when a change was made. If for whatever reason, you got to know that. But yeah, programmers use this website, and it's open. You can go to this website right here. There's a link to it on the main page right at the beginning, right here. There's a link to it. And it's all open. It's right there. And an interesting benefit of this is because it's open, technically, anyone can contribute to this. Meaning, if you see a typo on one of the pages, you can actually be the person to go fix that typo and submit it. I see it and go like, oh, approve. And then it just automatically gets integrated into the website. It's pretty cool. And you can see here, there's a bunch of people that actually had contributed already. It's the same thing for the course next semester as well, if you care. Here's all the core content for that one. And we had a total of 13 people from the class contributing, which is really cool. I think it's great. You can actually make yourself part of the content, right? You're contributing on yourself. There's a couple ways to contribute. You can create just issues where maybe you don't feel comfortable actually making any changes, but you see a typo, yeah, you could report it with an issue, right? You go to issues and hit new issue, and anyone can just do this. And you can also make changes if you'd like, but we can talk about that later because it is a little bit more complex for where we are right now. Anyways, so that's a little bit about the course website. All right, so yeah, back to any questions about that, what I just talked about? Nothing? Okay. The last time we were talking about statements and expressions, and we just finished it up. And now I'm going to talk a bit about input and changing types. Chances are, if you've already done the lab, or if you did the lab exercises, you already probably came across this, but we'll talk about it here. We have print. Print is a great function for getting data out, outputting information. There's some data, you use print, and it displays it. Input, as you could probably guess, is a great way to input information. Pardon me. If I use input, it allows me to put data into the program, where I can type like, hello, and it'll work. I'm going to copy this code right here. Come on, new block. See, I use the function input. I gave it the parameter, we call this a parameter. I put just a string in there, give me a value, and that's what gets displayed here. You don't actually need to put anything in here. And for those of you that have already did some of the caddis problems, you're going to be using it more like this because we don't want any extra output. But now I could add information, 1, 2, 3, 4, 5, and hit enter. Great. Now the variable, my inputted value, has the value 1, 2, 3, 4, 5. Great. But what do you notice about that value? Anything particular you notice about it?
It's a string.
It's a string, which is fine. There's nothing wrong with that. But Python will always assume anything you input is a string. I entered 1, 2, 3, 4, 5, and it's a string. But what if I wanted it to be 12,345? Well, that's going to be a problem because if I wanted to do something like, here, let's do a little bit different here. B equals input, print, A plus B. There. So this little program here is going to read input twice, and then we're going to print out the sum of A and B. At least that's my intention. My intention is I want to put in two numbers and print out their sum. So I'll give 1 and 1, and of course, it's 11. But why is it 11? It should be 2. Well, it's 11 because I inputted the string 1. And then I inputted the string 1 again. And what happens when you use addition on strings? Remember? Just concatenates the strings. It puts them together. So 1 plus 1 with strings is just 1, 1. It's the string 1, 1. Now, if I were to type something like hello world, well, yeah, okay, this makes more sense because, yeah, you know they're strings. But if I was expecting them to be integers, I'd be having a big problem right now. So the easy way to do this is to just convert them to integers. If I write int around input like this, I've now nested the input function within that int there, meaning it calls input, it reads the input, so then input kind of is replaced with the value that you inputted, and then it'll automatically call int and try to convert it to an integer. So now if I hit run and I say 1, 1, I get 2. Because I said, okay, input, but you're an integer. Now I did this all on one line here. If you like it on one line, great. If you don't, that's okay. What we can do is we can say, okay, A equals the int version of A. B equals the int version of B. So now I've separated it onto two lines. Right? So I didn't call input and immediately do int on the same line. As I called input, stored the result in the variable A. Then I said, okay, turn whatever the value of variable A is into an integer and put it into variable A. So it read it in as a string. It read in the string 1, stored it in A. A has the value 1, but it's a string. Then I say, okay, take the value 1 that's a string that's stored in A, convert it to an int, which is now just the integer 1, and put it back in A. So the string 1 is now gone. It's obliterated, and we've replaced it with the integer 1. We did the same thing with B as well, and then we added them together. But what do you think is going to happen if I do hello? Well, we can't do that. Value error. Invalid literal for int with base 10. Hello. It's basically saying I can't turn the string hello into an integer. And if you're wondering, well, why not? Well, if I tell you to turn the string, who am I going to pick on? You, right there. Turn the string 1, 2 into an integer. I meant you. Yeah, you. Yeah, just what is the string 12 as an integer? It might sound like a trick question, but it's just 12. It's just it. Okay, 12. Great. You turn the string 44 into an integer. 44. Great. You turn the string hello into an integer. No, that doesn't make sense. That's a nonsense question, right? That doesn't make sense. So Python's telling you, you asked me to do something that I can't do. Did you really mean this? Because that doesn't make any sense, right? So it's not that, oh, Python couldn't do it. Well, neither could you. So relax. It's just I asked it to do something it can't do. So this is another one of those errors that we'll see, right? Remember we saw errors when trying to say like 1 plus hello. Well, that doesn't work, right? 1 plus hello, well, it's, I can't add an integer in a string, right? There's a whole bunch of these error messages that you're going to see. If you ever don't know what it's telling you, Python's error messages are kind of helpful. They're pretty good at telling you what the issue is if you know what you're doing. But when in doubt, just copy. The number of times I've done literally this, I couldn't even count anymore. I just copy and paste the error. And look, someone in 2013 asked that exact question. I can guarantee you this question has probably been asked a bajillion times. So good news is people talk about it on the internet, and you find solutions on the internet. It's great. Other programming languages can have very terrible error messages that aren't helpful at all. Python is pretty nice. Okay, any questions about what we just saw? I just kind of blitzed through. What I just showed you is basically all the content of this page, so I'm going to go through it a little slower again. But any questions about what we saw? Not the error message specifically, but any of the input and converting to an int. Cool. All right. Remember to ask questions. It gets really boring if I just talk for an hour straight. Okay, so great. Input, and whatever I put in here, the string, will be what gets displayed to the user, but you don't actually have to put anything in there. You can leave it blank, and it'll still prompt the user, as we saw with what I was doing, right? Whoop. I go back up here, hit run. See, it didn't display anything, but it's waiting for input. Input, and it'll bust. Okay, if you run the above code, you will see, give me a value. Python will wait. The program is hanged to wait until you enter something. Once the user enters the value, it will be stored in the variable myInputted value. That variable name's arbitrary, you could call it whatever, just give it a good name. And the string between the parentheses is what's displayed to the user, like I just said, but it's entirely optional, so you can leave it blank. And you're going to want to, if you ever type something like this on Caddis, it doesn't matter if you have the exact right answer. If you type something like that into Caddis, it'll say you're wrong. Because it'll count that string as part of the output, and if the outputs don't match, it'll be mad. So that's why in Caddis, you only ever write just input, open, close parentheses. All right, so quick activity time. I've been talking for a while. If you've got your computer in Colab open, just do this. Try this. And remember, don't forget the type function that tells you the type of things. I already kind of spoiled this one for you. But yeah, just do a quick little practice of reading input into, chances are, raise your hand if you've done the lab already. Raise your hand if you are going to the lab today and done the pre-lab exercises already. Okay, so it looks like everyone here has already done this. So we don't need to actually do this one, let's say. Long story short, we read in the data, stored it in a variable, but what is the type of the value that was provided? It's always a string. If you forget that it's always a string, well, the good news is you might get some really funky results, like 1 plus 1 is 11, should tell you something's wrong. That's why it's also really important to always, verify your code, right? Don't just write it and be like, okay, I'm done. Well, write it and make sure it works the way it should. Okay, the type of an input value, it's always going to be a string. And it might be, it's going to be obvious when you're inputting something like hello world. Well, yeah, that's a string. But if you enter 1, it's going to assume it's a string. So you got to be careful if you want to actually have the string 1, or do you want it to be the integer 1 because you want to do some operations on it. All right, so there you go. This is the example of what I showed before. My value is a string, read the input in. Then convert it to an int and store it in the variable, my value as int. Great. So in this particular example, I didn't overwrite the original variable. I didn't overwrite the original variable, I created a new variable because. All right, in the above example, if we enter 1, the value of my value as a string will be the string 1. On the next slide, we are taking the value of my value as string, which is the string 1, and we're converting it to an integer with that int parentheses. We put the thing we want to convert to an int between the parentheses. After everything, the value of my value as int will be the integer 1, and it's ready for arithmetic or whatever you want to do with it. You can do it all on one line like I showed you a moment ago by saying int, input, give me the value. It'll achieve the exact same thing, but it's on one line of code, so it's like we cut out the middleman, great. You might be thinking, oh, obviously I'm going to do it, I'm going to like nest it like that, because one line of code is better than 2 lines of code if I can do it. And that's not really correct. It'd be one thing if this was 40 years ago, and we were worried about how big our scripts are because computers were terrible back then, and how much space it took up. That extra couple bytes it's too much for me. If I'm really trying to optimize the length of my scripts, sure, that might be better. But I don't know, to me, this might not be the best example to convey what I'm trying to say right now, but sometimes verbose code can be really handy because it ends up being like very descriptive. It ends up being very clear as to what's happening. Sure, the input, yeah, it's not a great example because chances are you'll be doing this because why wouldn't you, right? But, this one line of code, that's a lot to chew on. You might find that to be like, oh, okay, there's a lot going on there, and you're right. So kind of splitting it out and making like each step more explicit, you might find that handier because it's a little easier for you to follow, and other programmers might find it easier to follow too. Code that's descriptive is better than code that's short, if that makes sense. Like if that's your metric only. Now there could be really descriptive short code, of course, but sometimes the verboseness could be handy. Changing types, okay, great. So it's stored as a string, I want it to be an int. Wrap it in int. What do you think I would do if I didn't want it to be an int, but I wanted to convert it to a float? What would I write? Who's brave enough to take a wild guess? Float. Go figure. What happens if you have the integer 1 and you want to convert it to a string? What do you think you do? The string one, yeah, but str specifically. In fact, I think I showed you that one. So, yeah. If you really do want that integer to be a string, okay, convert it to a string. Great, handy. And you might find that really handy, especially when you're outputting, when you're printing stuff, because what happens, here's a funny little quirk, print is plus A. So remember, we can concatenate strings with plus. So this could be a way I might want to output the value. I say the value of A is, and then I end the string, and then I do a plus A, because A is the variable holding the value I want to output. So in this case, if I enter 1, I want the output to say the value of A is colon space 1. That would be a way to do this, if it worked. Because when I hit run, what's going to happen? 1. I can't concatenate a string and an integer. You can't do that. So the easy thing to do is, well, just convert that integer to a string. How? Just wrap it in str. 1. Now it works. Great. This is one of those quirks that I show you once, you're probably going to forget, you're going to run into it. Don't worry, you'll become so familiar with bugs that as soon as you, like, that's how you end up learning. It's because you see the bug and you're like, I've seen it before, I remember. It's just part of the process. So there you go. Now if you're wondering, well, that's a stupid program. You inputted the value, you turned it to an int, and then you immediately turned it back to a string. You're right, it is. I'm just showing you as an example. Realistically, this is very useless. All right, here's a good activity. Write a program to, I'll give you a couple minutes to work on this one. Write a program to ask the user for a weight in pounds, save it to a variable, convert the inputted value to a float, save it to a variable, calculate the mass of an individual in kilograms based on the inputted weight, save it to a variable, print out the mass in kilograms. There, go. I'll give you like 3 minutes to work on this one, see if you can get it working in that time. If you have any questions when doing it too, you can, bug people around you, raise your hand, whatever.
Professor,
Yes.
it's regarding the lab. Can I ask you later or can I ask you now?
Ask later, yeah. Remember, when in doubt, if you're hitting run and you're a little worried, like, is this the right type? What value does it currently have? Throw an extra print in there, just to see what happens. Print out the type of the variable, just to see what happens. You might find that handy. Raise your hand if you're done. Raise your hand if you'll be done if I give you like just 30 more seconds type thing. All right, keep going, keep going. I'm gonna start filling it in because I got the first line there, read in the pounds. But of course, that'll save it as a string. I want it as an integer, so oops. I'm just going to overwrite pounds with the int version of pounds. Okay. So there's that step. So there's 1 and 2 done. So kilograms is going to be equal to the weight in pounds times whatever that value is. 453592. Great. And then print. Looks good. There. Who here had something more or less this? Cool. Now, did anyone try and not get it quite working? Because if that's the case, I just want to know what it was and see if we can address it. No one made any mistakes. See, that's very unlikely because everyone's always making mistakes in programming. It's what you're supposed to do. So there we go. Cool. All I did is I read in the data 200. I converted the value that was stored in pounds, which was the string 200. I converted it to an integer and stored it back in the variable pounds. So I took pounds, which stored, let's see if I can actually, like this is what happened. Dry erase. Pounds, I'm just going to draw it like as a box. Can you see that at the back? The marker's not great. Not really? Well, sorry. I entered 200. I put the quotes around it because it's the string 200. On that second line there where I said pounds, turn it to an int, put it back in pounds, I effectively did this. All right, goodbye. Just 200 now, just at the int version. So I just changed what was stored in that variable. I reused that variable. I could have made it another variable. There. This is perhaps better. It's a little bit more explicit on what it's doing. So now I'm not reusing a variable, I've got a separate variable, great. If you're thinking, oh, isn't it better to reuse the variable? It uses less memory. Yeah, you're right, but it doesn't matter. It's not going to affect it in this scenario. And then I printed out the mass in kilograms, just print it out. Oh, pardon me, calculate it by just multiplying it by that conversion rate. 0.453592. How did I know that? I just Google it, and there we go. Cool. Any questions about that conversion? So no one didn't get it quite working. Yeah.
I messed it up at first there because I tried to put the flow function in the, or like the flow in the same thing as the input, but then I realized I put a message as well, so I was trying to turn a string.
Ah, there you go.
And I just put in 2 lines.
Yeah, and see, and it's that feedback from the error message that just tells you what's up, right?
Yeah.
You're like, oh yeah, okay, I know what to do. And if you don't immediately know, that's fine, you're just learning. You're gonna, trust me, you're gonna make enough mistakes that you're gonna start getting familiar with the error messages and what they mean and how to fix them. There are errors that tell you what's wrong, and then there are errors where it just didn't work the way you had intended. The example would be that summation of the 2 strings, 1 and 1. There's clearly an error there. If my intention is to sum the 2 integers, but I gave it 2 strings and then it just concatenates the strings and prints it out, that's an error, But Python didn't give me an error message because what does Python know about what you wanted? So those are the sneaky errors where they pop up, but Python didn't tell you about them. So when you get an error message, consider yourself lucky because it's trying to be helpful. Any other questions about this input and converting types? Did anyone do this, but they didn't convert it to an int, they converted it to a float instead? No, you did. A couple people. Good, there you go. Let me guess, you're thinking, well, I'm multiplying it by a decimal anyways, so I might as well just make it a float. Yeah, you're totally right. Maybe I should have done that. It still works this way because when you multiply an integer and a float, it'll automatically turn it into a float. But having it as a float in the first place, good idea. And you'll start to notice that at this stage, it's not going to be that clear because at this stage, you're new, the programs we're writing, the scripts we're writing, the lines of code we're writing are not overly complex. But very soon, they're going to be growing in complexity. And very soon, it'll become quite clear on how everyone in here could have different code. I don't just mean different variable names. I mean their code could be quite different, and you're all correct. Think of it this way. There are 3 ways we like to ask questions in computer science. These are the types of questions you'll get on exams, for example, or assignments and whatever. As I will say, here's the input, I want this output. So your job is to come up with, well, what's the functionality I need? What's that thing in between to get me from that input to the output? That would be like what I showed you there, right? I'm going to give you this input, give me the output in kilograms, right? So it's your job to, okay, well, what's the code to do that? What that box looks like, what you put in that functionality can be very different from one another and still be entirely correct. Something as small as int float, small, but it's different, and we're both right. Sometimes we like to ask questions where it's, here's the input, here's the functionality, here's the code. Tell me what the output is. So it's your job to kind of like execute what the computer does. And sometimes the really fun ones are, here's the function, here's the output. What input would I have needed to get that output? I like those ones. Those ones are fun. Okay, great. Any other last questions, thoughts, comments, concerns, points, ideas? All right, functions. So what have we learned so far? We learned about values and types. We've learned, print and input and changing types around, great. Variables, like, literals and variables, great. Those are like the really key important things we've learned so far. Right now, what I'm doing is I'm equipping your tool belt with all the different tools. You've got your variable tool, you've got your, you know about the types and whatnot. The next tool we're going to add to the tool belt is functions. And you've already been using functions. Input, print, type. You've already been using these functions. But we can write our own functions. We can make our own. So scripts, programs, one line at a time is great and all, but obviously if you want to solve complex problems, you're going to need more than one line of code to solve your problem. You might need dozens, hundreds, thousands of lines. And they're a great way to organize statements, but eventually you're going to find you're reusing, like you might be writing the same code over and over and over again. The same chunks of code over and over. And that's really annoying. And that's really annoying because maybe you're smart and you're copying and pasting great. But it's still problematic because when you have this situation, one, it's annoying, it's tedious, it's a pain. I don't want to do that. And it's notorious for introducing errors because if you have the same code over and over and over again, maybe you've reused it 10 times, and then you discover there's a little bug in that chunk of code that you wrote, and you fixed it 8 out of the 10 times. You accidentally missed the one. But you don't really notice. The next thing you know, you're using your program, but it actually has a bug in it that you didn't notice. So that's a nightmare. You don't want that. And your code becomes very difficult to maintain, just like I was talking about. You want to change that chunk of code you were using all the time? Well, go through and find every piece and redo it and change it all over, and there you go. Oh, another change, great, do it again. It's a nightmare, it's a pain. You don't want to do that. Instead, we write functions. All of the code needed for print to work was written by someone else. You didn't have to write that function. You didn't need to care about the symbol that you want to print to the screen, how to do it, which pixels on the display need to be turned on. You didn't need to worry about any of that. Thank God, right? That's a pain in the ass. I don't want to deal with that. Someone had to write it though. And once it's written, that's it. We can all use it. Great. You're going to hit cases where you need some functionality. You're going to write the function that you're going to need for solving certain problems. And every time you ever need to use it, once that function's written, all you'll ever need to do is just call that function. That's it. You don't even need to, if you write that function and it's working perfectly, you don't even need to remember how it works anymore. You can forget and just know, well, I just know that I can call this function and it does what it's supposed to do. Like print. Raise your hand if you went and looked at the code in Python for print. Do you need to? No. You don't need to know what it looks like in order to use it. Same kind of idea here. So we like to group together chunks of code that have a purpose. Chunks of code that is coherently, and they're tied together. You're not going to just take random blocks of code, shove them in a function. That's not all that helpful. But if we have a function like convert Celsius to Fahrenheit, that makes sense to make a function, let's say. Because, well, those 3 lines of code, those 4 lines, whatever, like those lines of code, they go together. If you're thinking to yourself, why did he do it in like 2 steps? Well, I just did it in 2 steps because the conversion. Instead of doing temp in Celsius times 9/5 plus 32 on 1 line, I did it in 2 lines because I just wanted to. Arguably, this is less clear because you might be like, but whatever. Those are the lines of code. That's a function right there. It starts with a special keyword called def for define. You've got the name of the function, similar to variable names. There are some rules, like you can't start with a number, that type of stuff. Use snake case. Make sure it's a descriptive name, so Celsius to Fahrenheit, that's a good one. Then you've got your parentheses, and between the parentheses, you start listing the parameters your function needs. Parameter is just a fancy way of saying a variable. It's a way I can give a specific value to the function to calculate it. Who here ever took math before? If you see f of x equals x plus 1, that's a really simple function. This is the name of the function. It's just f. Mathematicians are terrible at naming their functions. I'd call this add 1, but whatever. This is the parameter, x. If I say, here's my function, and then I ask you, what's f of 5? You go, oh, it's 5 plus 1, it's 6. What's f of 10? Oh, it's 10, it's 11, great. It's the same thing here. If you're thinking, oh, this is complicated. No, you've been doing this since you were, I don't know, this big? How tall are you when you learn about f of x? I don't know. Somewhere around here. It's just a function. That's it. I know it looks different because it's in Python syntax and not the math syntax you're used to, but the idea is the same. And you can have multiple. If I had f of x comma y and said x plus y and gave you 10 and 10, well, you just play the replace game. Anyways, after the parameter list, this specific function only takes 1 parameter. Temp in Celsius, See, a good descriptive name for the function's parameter, the variable temp in Celsius. Great. Then you have to have your colon. You got to put a colon. If you don't, Python's going to get really mad, and sometimes the error messages aren't helpful because it'll say the problem's on line this, but it's actually on the line above. It's a whole thing. Include your colons. Then, new line, and then very important, indent. Everything in the function you're writing, all the code you want to be part of the function named Celsius to Fahrenheit, is indented with it. If I wanted to continue writing code after that function that's not part of the function, great, just unindent and keep typing. So, above is an example definition of a function that converts a temperature from Celsius to Fahrenheit. The details of all parts are discussed in this topic. I just kind of blitzed through it in 2 seconds, but I'm going to talk about these things specifically. You can already probably get a sense of what's going on. It's a group of statements that serves a single purpose, and it can be reused every time we want to do the conversion without having to write the whole conversion formula out. Because who's going to remember that except for you? No one's going to remember that. I write it down once, great, I'm all set. So, this is how I define a function. Defining and then calling the function are two different things. This right here is the definition of the function f. The definition includes its name, the parameters, and the body of the like what the function is. When you call the function, this isn't calling the function, this is just defining it. When I say, tell me what f of 10 is, there. That's me using this function. We're calling it now. So there's a difference between defining and using. You define it once, you can call it a bajillion times. So here's how we would call Celsius to Fahrenheit. You've called print a bunch. Someone defined it already, so you didn't have to define it. But you called print a lot already. So here's calling Celsius to Fahrenheit. I would write the code, Celsius to Fahrenheit, and then I specify within the parameters what values I want. So let me go do this real quick here. Copy. Okay. So I've defined the function. Now I'm going to start using it. Let's do print Celsius to Fahrenheit at 0. There. Great. I define it once, and I called it 3 times. Yes?
I'm following along with your code, but I can't get the indent that you have. Is there a special button you can
Just tab? Does tab not work for you?
No.
Really?
Mine automatically did it.
Yours automatically did it?
Mine's not doing it.
Your mine? So even if you just go here, press, whoops.
It does like a single space when I hit tab.
Oh, a single space or 2 spaces?
A single space.
It's single. There is a setting to change how wide your indents are.
Okay.
But if with the single space, does it work? It doesn't. Because if I do it like this, yeah, indentation there. Do you get something like that?
Yeah.
So if the tab's really not working, you can do 1, 2, 3, 4 spaces. Just try adding 4 spaces and let me know if it works.
Okay.
Yes?
We had different errors as unexpected EFO while parsing.
Unexpected EFO while parsing. EFO means end of file. So chances are we've got, hold on. Give me 1 second here. Because single space worked for me. But the convention would be 4 spaces. A lot of times too, if you do use a tab, The text editors will even, just convert them to 4 spaces anyways, just so you don't mix up tabs and spaces. If you're ever programming on your own computer, never mix up tabs and spaces. If you use tabs and then switch to using 4 spaces throughout your program, it won't work. That's why most editors, almost all, if you hit tab, it'll just turn it into 4 spaces because it eliminates that error. But did it work for you?
I'm still going.
You're still going? Okay, cool. Now you said unexpected end of file. Was it a missing parenthesis or something?
Yeah.
Ha, look at that, see? I've seen that error before. Why? Because I've made that mistake countless times and I knew what it meant. So now whenever you see it, you go look for a missing parenthesis or something. If I forget the colon and I hit run,
What did yes mean?
pardon?
What did you say yes meant?
End of file. It means unexpected end of file, meaning that it was like, okay, well, I had an open, and everything after the open is supposed to be within that open, and suddenly I found the end without seeing it close. Uh-oh. That's all. Syntax error. Oh, the bugs got better. The message got better for the missing colon now. So there. Cool. So there we go. I defined it once, right here, and then I'm calling it down here. The function, the code that's outside the function is unindented. The code you want in the function is what's indented in. If you had something like this, and you're wondering why is nothing happening, it's because you never called the function. You never actually called it because all you did was define it. There's no code that Python's actually going to run. Python will only run the code in the function when it's called. The way it goes is Python sees, let's go back to the way it should be. Right here, Python starts at line 1 and goes, oh, def Celsius to Fahrenheit. Okay, there's a function, I'm going to remember it. Great. It's going to jump down to line 6, which is actually the first line of code that Python's going to run. It prints out the result of Celsius to Fahrenheit. Oh, okay, so I'm going to go jump to that function, do the calculation, and then return the result back to be printed out. Line 7, same thing. Line 8, same thing. There we go. Calling the function. It's always good to test your functions. See, I tested a couple. I knew that 0 Celsius is 32 Fahrenheit. I knew negative 40 is the same, so it's a good way to test it. When we call a function, Python executes statements within the function in the order that they appear. Yeah. Functions allow for reuse. Just recall that function every time you need it. Maintainability. If there's a bug, you only need to change it once. And it's fixed everywhere it's called. Readability. The name of the function. You know how we like to give good names to variables, so if I look at the variable, I should, that context helps me figure out what the code's actually doing. Great. But, that's naming a variable, that's naming data. What if we want to name the functionality? So it becomes really obvious. A line of code that says Celsius to Fahrenheit, if you read that, you're immediately going to go, oh, it's a function that's converting Celsius to Fahrenheit. Great. It's obvious because it's named well. If you just see C times 9